Okay, Assalamualaikum and good day. So today we continue back with our lecture 1.2 but different probability function. So previously you have learned binomial probability distribution function, geometric probability distribution function and negative binomial probability distribution function. So now we will move to hypergeometric probability distribution function. So before that, okay, definition 3.10, a random y is said to have a hypergeometric probability distribution function if and only if you have probability and this equation. Okay, so first of all, how you get this equation ni? Alright, so if you look here, okay, suppose that a population contains a finite number of n element that possess one of two characteristics. That means when we're talking about population, you will have capital N like this. Alright, and then possess one of two characteristics. From 2, you have 1. Okay, so let's say, okay, R of element might be red. Let's say we have we have certain things. Okay, some is red, some is black. So R of element might be red. And then we have B, which is capital N minus R, we get black. Alright, let's say in one circle here, we have red and we have black bubble or black marble. Okay, so R element might be red, and then how you get the rest? Capital N minus R. Okay, and then a sample of n element is randomly selected. So from capital N here, you select sample. Alright, so n element is randomly selected from the population, and the random variable of interest is y, which is number of red element in the sample. So from this sample n, we want to see what is the red value. Okay, so this is called hypergeometric probability distribution function. So that's why you will get this PMS. Okay, that's mean you have from R, Y is number of R, how many? And then from capital population minus minus R, and then you have sample minus Y, and then divide by all total. Okay, so where your Y is from 0, 1, 2 until N, and then subject to restriction, your Y value should be less than R, and then N minus Y should be less than capital N minus R. So clear lah, isn't it? Because Y ni is the number of red element in the sample. That means this is sample. We want to see Y. Y is number of R. Okay, so that's why here Y should be less than R here. And then this N minus Y should be less than N minus R. So this is N minus R. Here is N minus Y. And then all this must be divided total. From capital N, we take N, isn't it? So that's why we have this PDF function. Alright? Okay, so now we move to the example. Alright? An important problem encountered by personnel director and others faced with the selection of the best in a finite set of elements is exemplified by the following scenario. Okay? From a group of 20 PhD engineers, 10 are randomly selected. So you can see that this is your capital N. Okay, we have 20 PhD engineers, 10 randomly selected, which is your N, small n, okay, for employment. The question asks you, what is the probability that 10 selected include all the 5 engineers in the group of 20? So they ask you to find the probability, which is P lah. What is the probability, isn't it? Okay, but from here you can see that 10 selected, which is sample, 5 best engineer. So 5 is your R, which is element that they're interested to study, which is engineers, best engineers. Okay, not a poor engineer, but best engineer. Include all the best engineer. That means from 22, the best engineer, they only have 5. So that's why here they consider all the 5 best engineer. Alright. So important here, you must know your capital N is 20, sample size is 10, and then your R is 5. R is the element that you want to study or you interested to. Alright. So in order to find the probability that Y equal to 5, so you will use the hypogeometric probability distribution function. So you just substitute the value inside the formula here. So you know lah what is your R, what is your capital N, what is your Y, alright? So here your Y should be equal to 5 lah, because they want to see if all the 5 best engineer. Okay? Yeah lah. Okay? Find the probability that Y equal to 5. So when you substitute the value, you use calculator, then you get 0.0162. Alright. So if you look at the right side ni, your book, okay, this is show you how is it lah. How is the formula? How you get the formula like this. Alright. Okay, so now important is your theorem. Okay, so theorem 3.10. Alright, if Y is a random variable with a hypergeometric distribution, so the mean or the expected mean will be NR divided by capital N, and this is the variance. Okay, variance squared is Vy, and then you get this one. Okay, so homework, try prove the mean and the variances as well. Okay, for this one as well. Alright, so if you look from the table, you can see something here which can help you lah, how to do this. Alright, okay, so then we move to example 3.17. Okay, an industrial product is shipped in lots of 20. Okay, testing to determine whether an item is defective is costly. Okay, and hence the manufacturer sample his production rather than using 100% inspection plan. So if you look the first sentence and the second sentence, to some information for you. Alright, so but you can see that the first sentence, an industrial product is shipped in lots of 20. Okay, right. A sampling plan constructed to minimize the number of defective. So this is the objective. They want to minimize the number of defective shipped to customer. So they call for sampling 5 items. Okay, so first lots of 20, and then sample 5 items. So this one you can see this is your N5, isn't it? From each lot and rejecting the lot if more than one defective observed. Okay, so if the lot is rejected, each item in it later tested. Alright, so A, if a lot contains 4 defective, what is the probability that it will be rejected? Right, if you look solution here, first, what is your Y? Okay, Y is equal the number of defective in the sample. Because first study, you know that your ship is equal to 20. Then they are talking about defective. They want to minimize the number of defective ship. And then from sampling 5 items for each lot, okay, if each lot, more than one defective is observed, so they will consider lah. Alright, so you can see your N is 20. Here, your R equal to 4. Okay, because question A, you can see if a lot contains 4 defective, And then your y is number of defective in a sample. And then your sample is equal with 5 here. Okay, so the lot will be rejected if y equal to 2, 3 or 4. Okay, because if you can see from each lot and rejecting the lot if more than one defective is observed. So when they say more than one defective is observed, that means if one, they will not reject. But if more than one, which is 2, 3, 4, then rejecting the lot. So what is the probability of rejecting the lot? So you will have y greater than equal to. So that means you have for 2, for 3 and for 4. Because we didn't know until how many, alright? So we will have 1 minus P0, P1. No defective at all or one defective. So this is probability for the geometric function, hypergeometric function. Okay, so you just substitute the value based on here. And then you get the probability 0.2487. Okay, and then question B. What is the expected number of defective in the sample of size 5? So when they ask you expected number of defective, that means they want you to find mean, which is EY. Okay, but here we know the mu for the hypergeometric function is this one. Okay, this one. And R over N. Okay, so you just use the formula. This one, you just use the formula. And R, okay, N is 5 times R divided by capital N. And then the variance, you just substitute the formula and then you get the value. Alright, so that's for hypergeometric function. Okay, so there are many more here, exercise that you can try your own. Okay. Okay, at least you try one by one, then you can see lah how is it. So I think that's all for hypergeometric distribution function. Thank you.